Hi everyone, this is Chandrakant, and today we are going to discuss the second part of the two-port network. Here we discuss interrelationship among various parameters. First we will discuss the between Z to Y or Y to Z, whatever way you can say, Z to Y. The first step is write the Z parameters equation. First step is your write Z parameters equations. Then Z parameters equation is the V equal to G and I. All these are matrix. To every time I would include bracket. So I'll multiply G inverse matrix inverse V is equal to G inverse G I. So G inverse, because G is the matrix, 2 into 2 square matrix, so this will be I, that is your identity matrix. And you know this is the identity matrix. So this is when you multiply any matrix with the identity matrix, the matrix remains the same. So column matrix I is equal to G inverse V. Same thing is written in a single step. Okay, expanded relations. So if you look at this equation, it is clearly the relationship for the short circuit parameters or Y parameters. So your Y parameters is the inverse of G parameters. That is G parameters when it is written in the form of matrix. When you take the inverse, then you get the Y parameters. Very simple tricks to find the matrix, that is the inverse of a inverse of a 2 cross 2 matrix. Let's say this is your A, this is your B, this is your C, this is your D. We call this is your principal diagonal. This is called the principal diagonal. The elements are A and D. Okay, obviously this is the other diagonal. So whenever you are finding the, let's say it is your A inverse of this matrix, that is principal diagonal elements are interchanged and other diagonal elements remain there with a negative sign, and divide with the determinant of this matrix. Okay, determinant you know, AD, that is determinant of A is the AD minus BC. Same thing is done here. Principal diagonal elements are interchanged and other diagonal elements remains there with negative sign and divided by the determinant of the matrix. So from this, comparing the Y parameter with the G parameter, you can see that this is your Y11, this is your Y22. So Y11 upon Y22 is equal to GT2 upon G11. Similarly, Y12 upon Y21 is equal to G12 upon G21. And this is the Y matrix and G matrix. When you multiply, you get the identity matrix. There are enough hints you can utilize whether your calculation is correct or not, and you can easily arrive at your result. So this is straightforward, G to Y or Y to G, right? But a real challenge arises when you convert from G to T or G to H or Y to H, like that. The procedure straightforward. First, here we'll discuss the G to T transmission parameters. So from G to T, so first write the G parameters equation, that is V1 equal to G11 I1 and G12 I2 and V2 equal to G21 I1 plus G22 I2. Now, as I have told you, find the inverse of this equation, only, that is I1 I2 equal to inverse of G and V1 V2. Now go to the definition of T parameter. According to the T parameters, A equal to V1 upon V2, or you can write the T parameter for your reference like V1 equal to A, okay, A V2 minus B I2 and I1 equal to C V2 minus D I2. So obviously A equal to V1 upon V2 when I2 0, when I2 equal to 0. Now look at this equation. Can I get this result easily, or can I get this parameter A? You can get from both any pair of equations, okay, but you need to that's why I have converted into this form, so that which parameters I can use, which set of parameters I can use to get the A easily. You can see that from equation 1, if I put I2 equal to 0, I can easily get V1 upon V2. When I put the I2 equal to 0, you have V1 equal to G11 I1 and V2 equal to G21 I1. So obviously your A will be the V1 upon V2 equal to G11 upon G21. Clear? Now come to the B. How B is defined? B equal to V1 upon minus I2 when V2 equal to 0. You check here. You check here. V1 upon minus I2. V1 upon minus I2 when V2 equal to 0. Okay. So from this equation you can see here. From equation, yeah, V1 I2 and V2 equal to 0. From this equation, I2, from equation 2 of second set of the parameters, so you can see that I can write I2 equal to minus G21 del Z V1, okay, plus G11 del G V2. When I put the V2 equal to 0, I can get these parameters B, that is V1 upon minus I2. So V1 upon minus I2 will be the V1 upon minus I2 will be the del G upon G21, del G upon G21. Very straightforward. Now come to the parameter C. Parameter C is defined as I1 upon V2, I1 upon V2 when I2 equal to 0, I1 upon V2 when I2 equal to I1 upon V2 when I2 equal to 0. So you can see here is the answer here, second equation. Okay, put the I2 equal to 0. You can you put the I2 equal to 0 here, so you can get the I1 upon V2. So it is 1 upon G21. This equation, when this is 0, you can see I1 upon V2 equal to 1 upon G21. Now come to the fourth parameter D, which is I1 upon minus I2 when V2 equal to 0. See, same equation. Put the V2 equal to 0. You get the I1 upon minus I2 equal to G22 upon G21. I1 upon minus. So G22 upon G21, very clearly. So that's why that's the reason this is a process. First step right, first step second the equation with the inverse of that parameters, then you have 4 set of equation to choose from. Which one gives you the result very quickly or easily, you can use that, checking the parameters of the that is to which the parameter has to be converted. Now we will take the reverse way approach. Reverse, how we will do? Same way, first write T parameters. Okay, this is your G parameters, this is your T parameters. First write, because will be converting T to G. Okay, so write the T parameters, then inverse equation as usual. Okay, take the inverse of the ABCD matrix. So obviously DA minus B minus C. Now you have 4 set of equation 1, 2, equation 3, 4. Same way, this is just a manipulation. Okay, this is just a manipulation I have done here. Okay, I took out the negative sign for this equation and I cancel the negative sign for the other equation. You just manipulate it, or you can keep it as it is. This is very straightforward. When you write these equations, V2 will be the dV1 minus BI1. Okay, minus BI1, and your minus I2 will be the, but just I have done here, so minus I2, so I multiply the minus in the left hand, that is left hand side and right hand side. So ultimately I got this one. Now come to this equation I have written to recall the G parameter definition. So G11 is equal to V1 upon I1 when I2 equal to 0. Check the equation, which one can give you the result quickly. Okay, V1 I1 has to be related, V1 I1 has to be related, and when I2 equal to 0. See this equation, fourth equation, when I2 equal to 0, so your obviously del 2 will be multiplied, del t will be, that is the determinant will be multiplied by 0. So CV1 minus AI1, CV1 minus AI1, which is V1 upon I1 equal to A upon C. Now come to the G12. So G12 is defined as V1 upon I2, V1 upon I2 when I1 0, V1 upon I2 when I1 equal to 0. So equation from same equation 4, V1 I1 I2 related, V1 I1 I2. So I'll make I1 equal to 0. So I2 equal to 1 upon del t C V1. So V1 upon I2 will be the del t upon C. Del t, determinant of T matrix or transmission parameter matrix. Now come to the G21, V2 upon I1 when I2 equal to 0, equation 2, very clearly. V2 upon I1 when I2 equal to 0, so 1 upon C. When you practice more number of times on your own way, first write the standard equation and try to practice as much as possible, or simply write down the parameter conversion parameter, then only you will be able to identify which equation has to be do. because first you know 3 variables, every equation has the 3 variable. For example, I1, V2, I2, there are 4 equation. Check the what are the variable involved in the equation. Definitely one has to be made 0, one has to be made 0, and definitely ratio of the other 2 variables give the desired parameters. So G22 is equal to V2 upon I2 when I1 equal to 0. See, V2 I2 I1, V2 I2 I1, same equation 2, make I1 0. So V2 upon I2 equal to D upon C. You cannot remember like this, like when G parameters has given, A parameter, that is a transmission parameter has given, so G11 equal to A by C. No one can remember. Okay, if you try to remember, then all the other topics you have to forgo. Now come to the from H to T parameter. H parameters, hybrid parameters, H to T parameters. So same way process, first step, write the H parameters, V1, the relation between the V1 I2, H11 I1 plus H12 V2, and I2 is your H21 I1 plus H22 V2, and take the inverse of this equation, I1, because here the output, that is the relation is the input current and output voltage, or you can say port 1 current and port 2 voltage. So I1 V2 equal to 1 upon del H. Del H means determinant of H matrix. Same way, that inverse, that is the, this whole term is the inverse of the H parameter matrix, and V1 I2. Now you have 4 equation. Now you check how A is defined. A is defined as V1 upon V2 when I2 0, V1, V2, I2. Which one? V1, V2, I2. V1, V2, I1. Okay, here. V1, V2, I2. This one. When you make I2 0, so you have, you see, V2 equal to 1 upon del H minus H21 V1. So V1 upon V2 equal to minus del H upon H21. Same way you can come to the B, V1 upon minus I2 when V1 upon minus I2 when V2 equal to 0, when V2 equal to 0. So V1 I2 V2, V1 I2 V2, same equation, V1 I2 V2, same equation, but here we made V2 equal to 0. So 0 equal to, so del H vanishes, and V1 upon I2 will be the H11 upon H21. No, V1 upon minus I2. So obviously there will be a minus sign. So these are the small things. Don't complain that I have made the silly mistake in the examinations. So be stick to your conventions, and that too comes with the practices. Now come to the C. C equal to I1 upon V2 when I2 equal to I1 V2 I2. I1 V2 I2. C equation 2. I1 V2 I2, and make I2 equal to 0. So you have I1 upon V2 equal to minus H22 upon H21. Minus H22 upon H21. Similarly, you can go with the D. D is the I1 I2 V2, same equation, and you will have the, when V2 equal to 0, so I1 upon minus H2 equal to minus I2 equal to minus 1 upon H21. So with systematic approach you can do this. But now question arises, why we do the transformation from one parameter to the another parameters? The natural question should arise, like you are appearing in an interview and interviewer will ask you why it is needed to. The first is the convenience, because one parameters, like when the two parameters their connection is different, like cascaded, you have been given G parameters, that if you want to find overall characteristics of that combined circuit, then it will take longer, the sum becomes cumbersome, and it will take lot of time. So you need to convert into the transmission parameter, because we know when the networks are cascaded, their transmission parameters are simply multiplied. Okay, and you have been given transmission parameters. You connected in the parallel connection of the two network. So again we want to just we want to get the characteristic of that combined networks with through a parameters. So obviously the parallel connection, I need to convert the transmission parameter to the y parameters, because I know when the networks are connected in parallel, that means y parameters are added, individual y parameters are added to get the overall y parameters of the combined network. So that is the need, arises, that is to convert one parameter to the other parameter. Clear? So now come to the reciprocal and bilateral networks. Every year, almost every year you will find one question from the reciprocal and bilateral network. A network is said to be reciprocal. Very important point. A network is said to be reciprocal if the principle of reciprocity holds good. That means all, and reciprocity, principle of reciprocity means that is the ratio of voltage upon current in one port is equal to, that is the current in the other port is equal to same voltage in the other port, that is second port, that is when you connect the voltage in the second port and measure the current in the first port, that ratio remains same. And if this ratio remains same, that is we call it is a reciprocal network. All passive networks are reciprocal. All passive networks are reciprocal. Passive means you do not have any you can say any source in that network, any dependent source in the network, any source in that network. Passive, there is no energy sources in that network, then it is always reciprocal. Then come to the symmetrical network. Symmetrical network is one if port 1 and port 2 can be interchanged. We have seen the two-port networks. One has the one port. There are two ports. If their ports are identically behaves after the interchange of the, that means you connect the input in the port 1 and measure the response at the port 2, or to connect the input at the port 2 and measure the response at the port 1. If the characteristic does not change or the behavior does not change, we can say that it is a symmetrical network. So this is another important point. All passive symmetrical networks are reciprocal. All passive symmetrical networks are reciprocal, but converse is not necessarily true. That means all reciprocal networks are symmetrical is not always true. So these are the conditions. These are the conditions for reciprocal. First we will discuss the conditions for the reciprocals, and then we will discuss the conditions for symmetrical. For G parameter, it can be very well proved also, okay, through your network parameters. For G parameters, for reciprocal, G12 equal to G21. That means this one, G12 equal to G21. That is, other diagonal elements are equal. Obviously, as they are dual of each other, obviously that holds good also for the Y parameter. And okay, we'll do parallelly so that it will be easy to understand. Now condition for symmetrical. When the principal diagonal elements are equal for G parameter, that is G11 equal to G22. Obviously, see, it is very simple. If you remember, because G is dual of Y, T is dual of inverse T, H is dual of G. So in a nutshell, actually we are learning 3 type of network parameters. If you just omit the inverse G, T and H, and Y is the inverse of G, T inverse is the inverse of T, and G is the inverse of H. They have identical. So very easy to remember. Now for T, if the T parameter has been given, then how to know whether the network is reciprocal? That is, determinant is equal to 1. Determinant is equal to 1. Similarly, for T inverse, determinant is equal to 1 because they are dual of each other. And condition for symmetrical, A equal to D, like your G parameters. So you just see here, all 4 parameters have equal conditions for symmetrical. Okay, all 4 parameters are equal for symmetrical, but for reciprocal it is different for the T. Now come to the H. H parameters is symmetrical. How can you know? When H12 is equal to negative of the H21. H12 is equal to negative of the H21. So you can say almost similar to the G parameter, Y parameter, but with a negative sign. As G is the reciprocal of H, so obviously it follows the properties of the, or follows the characteristics of the H. And H parameter is symmetrical. How you know? It is the determinant of H parameter matrix is the 1. If it is 1, then it is symmetrical. Similarly, the G is the determinant of G parameters is 1, then it is symmetrical. Okay, hope it is very clear. Now I have told before, whenever the two networks are cascaded one after other, cascaded means one after other it is connected. This is the cascade connections. If a network A, network B, and A have A, B, A parameters, C, A, D, A, then A, B, 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 C, B, dB, and this is your V1 I1, this is your V2 I2, V3 I3. Just write the equation and replace, and you will find that I1 V1 I1 is equal to overall, that is the transmission parameter is the product of individual transmission parameter. AB, BB, CB, DB, and V3 minus I3. You can easily get it. That is, when the networks are connected in cascaded, then individual transmission parameters are multiplied. Okay, so clear the cascaded connection. Now come to the series connections. This type of connection is called the series connections, because you see this network X and network Y are in the series, because V1 is equal to this voltage plus this voltage. Okay, so series connection. Same way V2 equal to this voltage. You can write individual connection, then sum of the voltage V1 equal to this V1x plus V1y, and you will get the, easily you can get the this, that is individual G parameters are added. When the connection is the series, you need to identify which one is the series connections. Okay, sometimes directly calculating the parameters may take a lot of time, but if you can easily identify the series, this connection types, that is series connection or parallel connections, then that means you are bifurcating the problem, dividing the problem into the smaller one, then adding together you will get the overall G parameters. Many times the question has been appeared in the competitive exams. Competitive exam is both in GATE and in the ES exam. There are two in the two topmost competitive exam. How to identify the parallel connection? Same voltage is applied in the across the both the network. Okay, you can see V1 here also appear, V1 here also appear, V2 here also appear, here also appear. That means this is a parallel connection. So Y parameters are added. Individual Y parameters are added to get the overall Y parameters. Case 3. Input side is, that is port 1 is series, port 2 is parallel. We call it series parallel connections. So series parallel connection is the which type of connection? H parameters type connection. You can easily see that the equation, from the equation you can see V1 is equal to H11 I1 plus H12 V2. That means we are here connection, because here the input side we are writing the equation, okay, as a series connection type, as a voltage equation, open circuit equation, and in the output side or port 2 side we are writing I2 equal to H21 I1 plus H22 V2. Which type of equation? That means parallel or short circuit type equation. You just remember your G parameter, how we calculate your G parameter, Y parameter. G parameter V1 is related to I1 I2, okay, because V1 is the connected I2, that is open circuit in the input side, okay, and short circuit for the Y parameters, for short circuit the current equations. So open circuit means this is the series, when it is the series connection in the input side, and short circuit is the parallel connection in the, that means it is. So when you find the individual parameters, write the individual parameters, and you will see that your, in this case, your H parameter getting added up. When you solve this, when you simplify this, writing the H parameters, because this is your V1x, this is your V1y, and this is your V2, and this is your V2, same V2, V2x and V2y, and current is the here I2x, I2y. When you write the individual equation and eliminate the all the intermediary values V1x, V1y, I1x, I2x and I2y, you will get this. So in short, just add for memory, you remember when input side is the series, your H parameter is added, because input side is the voltage equation, that is the voltage is the dependent source V1, and current is the independent source. So this is will act as open circuit configuration. So series connection is the, in this case the series connection in the open side, that is your port 1 side, open connection. So H parameter match with that, so H parameters are added. Obviously another will be there. Input side is your parallel connection, or port 1 parallel, port 2 is the series. Here the is a dual of the this above networks. So obviously your G parameters are added. Now very important part, load terminated networks. Load terminated network. That means we have studied the characteristics of network, but when load is connected, so first step is the write the whatever the parameter equation has been given. For example, G parameter of this network has been given, network has been given. So I have written. Now see here, this is your convention I2. How VL is related? VL is equal to minus I2 GL. So put this value V2 is equal to V2 or VL. So V2 equal to minus GL, that is a load, okay, not the parameters, that is a load impedance, and I2, GL minus I2, okay. This is your, so from this you can find out I2 upon I1. From this you can find the ratio of, because this is I2, so minus I2 upon I1 is equal to minus G21 upon G22 plus GL. Now come to the input side. Yes or no? By input side I have to write. Input side, this V1 is equal to, just write the this side equation. V1 is equal to Vs minus Gs, that is the source impedance, into I2. This one. Okay. Now come to the how, see the, this is the very important case, input impedance. How you will calculate the input impedance? So input impedance is defined as is the Vs upon I1, because this is the source and this is the I1, that is Vs upon I1. So that means Zs plus this impedance Zd, and this is Zd is defined as V2 upon I1. So you can easily find out the, sorry, V1 upon I1, V1 upon I1. So from this equation, now see, V1 upon I1 is equal to, V1 upon I1 is equal to G11 plus G12 into I2 upon I1. I2 upon I1 you have already calculated. Put this value. This is a Zd, and your input impedance is equal to Zs plus Zd. Then output impedance, by definition Z0 is found by, first you set your load as infinity. What does it mean, infinity? That means you need to disconnect the load ZL. Then drive the port 2 with a voltage source V2, measure the current I2, the ratio, another thing I forgot, and port 1 the source should be reduced to 0, that is a voltage source we applied, reduced to 0 means short circuit, okay. Now from input side you see V1 is equal to minus Zs I1, and from, so by definition Z0 is equal to V2 upon I2, okay. So V2 upon I2, from equation 2, V2 upon I2 is equal to Z22 plus Z11 Z21 into I1 upon I2. But which I1 upon I2 you need to use? Because for this case, because already I1, not this I1 upon I2, that is the case when the ZL is connected, okay. But here ZL has been turned infinity. So as we have already calculated V1 equal to minus Gs I1, so put this value in the equation 1. So now you can get the I1 upon I2 and put this value, and you will get the total output impedance of the network. So this is the standard process we have done for the G parameters, and it can be done or it must be done and it should give the result, proper result, if the network is specified by any type of parameters out of 6 type of parameters. Okay, so you can go through this video again and again if you don't understand. First of all, the criteria is the without fail is the you need to use your pen and paper as many times as possible till you get the confidence in doing the all these manipulations. Now come to the, these are the some significance, though it is not important, but you just see here. The type of network is called the lattice network. This is called the lattice networks, a parallel arm and series arm. This is called the series arm, this is called the diagonal arm. Okay, ZA and ZD is called the series arms, and ZB and ZC is called the diagonal arms. And what is the symmetrical lattice networks? Symmetrical lattice network, the one ZA equal to ZD, ZB equal to ZC. Series arms are equal and parallel arms are equal. ZA, ZD, they are equal, and ZB, ZC equal. Then we call the same process. You can find out the G parameters for any networks as we have done. Bartlett's bisection theorem, though I don't know whether it is in the GATE syllabus or not, but it is very simple one. A two-port networks having mirror image symmetry can be reduced into an equivalent lattice structure, that is symmetric one. Okay, symmetric lattice structure where series arm is equal to Z SCH, that is the impedance of short circuit half, and diagonal arm is the ZOCH, that is the impedance of open circuit arm. First is the, what is this image, that is a mirror image symmetry, that need to be understood. If a network is like this, let's say 2 ohm, 2 ohm, 1 ohm. This is a mirror image symmetry, hidden mirror image symmetry, because I can write like this: 2 ohm and 2 ohm, and this is the mirror image symmetry. When I put a mirror here, whatever see in the image of that mirror, when I put a mirror here, I will see same network. Here also 2 ohm, 2 ohm. So that is called the mirror image symmetry. This is another type of mirror image symmetry, is the this one. Yeah, 3 ohm, 1 ohm, 1 ohm. This is also mirror image symmetry. Just 1.5 here, 1.5 here. I put a mirror, so I can see same resistance formation across the mirror. But this is not a mirror image symmetry. 3 ohm, 1 ohm, 2 ohm. This is not a mirror image symmetry. I cannot, because this is 1, this is 2. I cannot have any where I can put a mirror so that I can see the same formation across the mirror. I can never do. Okay. So whenever a network has mirror image symmetry like this, then I will bisect the Bartlett's bisection at the where I am putting the mirror. Once I bisect, I will have this. Then series arm is the, when I short the AB, ZSCH, impedance of short circuit half. When I short circuited, my ZA, or you can say series arm, is equal to simply Z1, impedance of the short circuit half, and ZB, that is the impedance of diagonal arm, is equal to the, when I open circuit half, that is Z1 plus 2Z. Now I can write. So network is same network. Okay, just I have converted into a symmetrical lattice network. Okay, So we'll move to the example. These are the typical networks. This is called the ladder network. This is a T, this is a pi, bridge network, lattice network we have just now discussed. It's called the bridge T. Bridge T is a type of connection we call the parallel network. This is one network and this is one network. This is the two networks are connected in the parallel. This is also same. Two networks are twin T. Two networks are connected in the parallel. Okay. This is a ES question. Match list 1 with the list 2. List 1 is the excitations. List 2 is the two-port parameters. Which excitation is related to the which type of parameters? I1, when the excitations in the both port is the current, obviously it is G, correct. When excitation in the both port is the voltage, is the Y, correct. And excitation as the input is V1 and the output is the in the port 2 is the I2, G, correct. Excitation I1 and okay, same sequence has been given here. Okay. Okay, we'll discuss the questions. Okay, I don't want to stretch this video for longer durations. Already it is above 40 minutes. So we'll discuss in the third part that some of the gate question in all the other examples, so that I can put more efforts, because the time is less now. I don't want to stretch to more than 1 hour for this video. So please go through this video again and again if you stuck somewhere, and you learn, then you work out with the example. In the next part we will discuss the gate questions and also some of the examples. Please subscribe and tell your friend to subscribe my channel, so that I can upload more and more video. When the time permits, I'll record the next. Will start as per my schedule. Already told to few people that I'll start with the device. Okay, with another one class I'll be the network theory will be over. So, and you can watch all the related videos in my playlist of the network theory. Okay, keep learning and try to do your best and put your best effort of your life, so that you can do best in your GATE 2023. Just keep motivated. Just think that how people are getting placed, how people are getting admission in the MTech in the topmost institute of India, right? And you know that VLSI field, for especially electronics and electrical, it's booming, and a place in the good institute in the MTech seats in the good topmost institute like old IITs and top NITs will land you in the great career opportunity or great company to work with. And you also living your dream, because you will be working in your core field. So just think that how the life would change once you crack the gate with a good rank.